This is going to be an optional lecture today. I'm going to go over the extra credit, which I gave a while back. It takes actually some work to do it, but it's an illustration of all the methods we learned in Chapter 7. All right, so the problem is to do the integral. This is the extra credit. The integral of y to the 2/3 dy over y plus 1. And the idea will be to do a substitution, which I gave the hint of, well, z cubed equals y. Why you do that? Well, I'm trying to get rid of the fractional power of y, and this will do it. So z cubed is y, 3z squared dz is equal to dy. And so we can do the substitution, and we get, so y to the 2/3 is z squared, right? And dy is 3z squared dz. And then we're over z cubed plus 1. In other words, it's 3z to the 4th power over z cubed plus 1 dz. Now we are in the world of partial fractions. So let's see what we have to do here. The first thing we need to do is get the numerator of the integrand to have degree less than the denominator. And the way you do that is to do a long division of z cubed plus 1 into z to the 4th. And if you do that, you will get, what will you get? You'll get a 3z. So then it goes, z cubed goes into the 3z to the 4th, 3z times. So you can get 3z to the 4th plus 3z. And you're going to get a negative 3z remainder. So this is going to be the integral of negative of 3z dz plus minus the integral of 3z dz over z cubed plus 1. Okay, so this is going to be the first integral can be easily done. It's 3/2 z squared. And then we're left with this integral, which I'm going to call integral number 1. Okay, so let me sort of box that off. So this, at the end of the day, I have to convert everything back to y, but let's do all the integrals in terms of z first. I'm going to box that off. Let's call this integral 0. So this is 0. Okay, so now I turn to the integral of 3z over z cubed plus 1. And the thing to note is that z cubed plus 1 has a root of minus 1, and you can use that to do a long division, and you'll see that the denominator factors as z plus 1 times z squared minus z plus 1. So if we do the partial fractions expansion, you're going to get an a over a z plus 1 plus a bx plus c, bz plus c, sorry, over z squared minus z plus 1. Okay, the rest, the partial fractions expansion, I'm not going to do all the algebra for you. Let me just tell you what the answer is. A will be minus 1, B will be 1, and C will be 1. So this will be equal to minus 1 over z plus 1 plus z plus 1 over z squared minus z plus 1. So what we get is that the integral number 1 is equal to there's a minus sign there at the top between the two integrals 0 and 1. We'll worry about that later. But integral number 1 is going to be given by the integral of, well, let's incorporate the minus sign in. Why not? Okay, so you're going to get, that makes the minus 1 and the z plus 1 a plus sign. So it becomes dz over z plus 1, and then minus the integral of z plus 1 dz over z squared minus z plus 1. And then the first of these integrals is given by let's call this it's going to be given by ln absolute value z plus 1 minus the integral of z plus 1 dz over z squared minus z plus 1. Okay, so that's let's call this this term here 2 and this term here 3. Okay, so we have to compute 3. Okay, I need more space, so I'm going to save the screen and erase some. So let me do that. It's taking a while. Okay, so I've erased the screen and I put at the top what we've gotten so far. So we still have to compute this integral that we're denoting by 3. So that's this integral right here. Okay, so let's try to do that. So the idea here is I'm going to complete the square. So I'm going to write z squared minus z plus 1. If you complete the square, you're going to get z minus 1/2 quantity squared plus, it looks like 3/4 to me. And so the integral 3 becomes, what does it become? It becomes, if you, so we're going to do another substitution. We're going to let u be z minus 1/2. So du is dz. And therefore, the integral 3 becomes the integral of z plus 1, which is u plus 3/2 dz over u squared plus 3/4. And I'm going to break this up into 2 separate integrals. It is u, there's a du, it shouldn't be a dz. U du over u squared plus 3/4 plus 3/2 du over u squared plus 3/4. Okay, so the first, so let's call this integral 4 and this integral 5. So let's deal with 4 first. 4 is easy. So integral 4, what we're going to do is we're going to let v equal u squared plus 3/4. That's going to be a standard substitution. dv is 2u du. In other words, 1/2 dv is du. So integral 4 becomes the integral of 1/2 dv over v. So that's 1/2 ln absolute value of v plus c. We'll add the c at the very end. And let's go back and put this in terms of u. So this is 1/2 ln u squared plus 3/4. And actually, we know what u squared plus 3/4 is. That's the same thing as 1/2. So that's u is z minus 1/2. So it's z minus 1/2 squared plus 3/4. Or if you like, 1/2 ln of the original denominator, which was z squared minus z plus 1. Okay, and you have to add a c. So that's going to be the value of integral 4. So so we have to do integral 5 now. Okay, so in order to facilitate that, I'm going to need some space. So what I'm going to do is I'm going to clear the screen and then I'll substitute the value of integral 3 in terms of 4 and 5. Okay, so we are now reduced to doing the last integral on the top of the screen, integral number 5, which is the integral of 3/2 du over u squared plus 3/4. And this will be a trig substitution. We're going to let 3/4 is the square of the square root of 3/2. So we're going to let u equal square root of 3/2 tangent of theta. Then du is the square root of 3/2 secant squared theta d theta. Okay, so that's good. I just noticed that there should be a sign change over here, I believe, if you go back to a previous slide. Okay, so this integral of 3/2 du over u squared plus 3/4 becomes the integral of 3/2 times the square root of 3/2 secant squared theta d theta. And on the bottom is 3/2 because of the trig identity secant squared theta. So we get a lot of cancellation. And this becomes square root of 3/2 theta plus c. Now, what is the square root of 3/2 theta plus c? Well, u is the square root of 3/2 tangent theta, so 2 over the square root of 3 times u is the tangent of theta. So theta is the arctangent of 2 over the square root of 3 times u. So the square root of 3/2 times theta plus c is the square root of 3/2, the arctangent of 2u over the square root of 3 plus c. Let me put the plus c at the very end. We don't need the plus c yet. Okay, so that's what you get so far. We have to now go back and convert this to z, and then finally at the very end we have to convert everything back to y. So this last thing I wrote is going to then be equal to the square root of 3/2 arctangent twice, well, what's u? U is z minus 1/2, so 2 times z minus 1/2 is 2z minus 1 over the square root of 3. So that's it in terms of z, and therefore we have computed integral 5 in terms of z. So let me indicate that here by putting it on the, clearing some space out and rewriting everything. Okay. Okay, so I substituted the value we got for integral number 5, and I put that on the top, and I made some space. And so this is now, we have to now go back and convert everything back into y. So y is equal to z cubed. So z is equal to y to the 1/3. That's what we have to remember. So we're going to get 3/2 y, z squared is going to be y to the 2/3 plus ln y to the 1/3 plus 1 minus 1/2 ln. So z squared is y to the 2/3 minus y to the 1/3 plus 1. And then lastly, we get a term of the form square root of 3/2 arctangent of 2 times y to the 1/3 minus 1 over the square root of 3 plus c. And if I didn't make any mistakes, algebraic mistakes, this is the actual answer to the extra credit problem. So that was used pretty much every method that we've encountered, except for maybe integration by parts. So, so there you go.